The story of a star begins deep within a cold, dark molecular cloud in space, where gravity starts to pull dust and gas together. As these particles clump and collide, they form a dense core that begins to heat up through gravitational compression. When the temperature in this core reaches about 10 million degrees Celsius, nuclear fusion ignites, and a new star is born. This process marks the birth of a protostar, a phase that can last for millions of years as the star stabilizes. One iconic example of a young star is the Orion Nebula's trapezium cluster, a stellar nursery shining brightly in our night sky. During this early stage, the star is powered by the fusion of hydrogen into helium in its core, producing immense energy. A star like our Sun spends most of its life in this stable phase called the main sequence, which can last billions of years. In the case of our Sun, it has been shining steadily for about 4.6 billion years, and it still has around 5 billion years to go. But when a star exhausts its hydrogen fuel, its fate diverges based on its initial mass, leading to different endgames. For stars smaller than about 8 times the mass of the Sun, such as Betelgeuse, they swell into a red giant, expanding exponentially. Betelgeuse, a red supergiant in Orion, is nearing the end of its life and is expected to go supernova someday soon. In astronomical terms, supergiants like Betelgeuse fuse heavier elements in their cores as they grow larger, creating layered shells of fusion activity. Eventually, the core collapses under gravity, triggering a catastrophic supernova explosion that can outshine entire galaxies temporarily. The supernova disperses elements like carbon, oxygen, and iron into space, enriching the cosmic environment for future generations. A supernova remnant like the Crab Nebula is a beautiful, complex display of expanding gas and dust resulting from such an explosion. In the aftermath of the explosion, what remains depends on the star's initial mass. Some leave behind neutron stars, others black holes. A neutron star, such as the one in the remnants of supernova 1987A, is incredibly dense, packing more mass than our Sun into a city-sized sphere. Some of the most massive stars, after their supernova phase, can collapse into black holes, regions of space with gravity so intense that nothing can escape. Black holes are often detected by their effects on nearby matter, such as accretion disks, emitting X-rays, or stars orbiting invisible points. In our universe, stellar evolution contributes to the cosmic cycle, creating the building blocks for new stars, planets, and eventually, life. The life cycle of a star is a testament to the dynamic and ever-changing universe we live in, constantly shaping the fabric of space. From the earliest seed within a molecular cloud to the explosive end of a supernova or silent collapse into a black hole, each star's story is unique. Take, for example, Sirius, the brightest star in the night sky, which is actually part of a binary system with a white dwarf companion. Sirius's companion was once a star like our Sun, but has exhausted its fuel and now exists as a dense white dwarf, a remnant core. White dwarfs like Sirius B slowly cool over billions of years, eventually fading away into cold, dark remnants called black dwarfs. The life cycle of stars is also influenced by their environments, where nearby stars can trigger new star formation through supernova shocks. Astronomers use powerful telescopes and sophisticated models to understand these stellar processes across different scales and conditions. This cosmic narrative reveals not just the life cycle of individual stars, but also the grand evolution of galaxies and the universe itself. Every star tells a story of creation, transformation, and ultimately, extinction, contributing to the complex tapestry of the cosmos. The death of a massive star, like a supernova, seed the universe, with elements essential for planets and living organisms. If we look at our own star, the Sun, it will eventually swell into a red giant before shedding its outer layers and becoming a white dwarf. The Sun's slow transformation will occur over billions of years, but understanding this life cycle helps us grasp our own future. Stars like Alpha Centauri, our closest stellar neighbors, follow similar evolutionary paths, helping scientists piece together stellar histories. By studying different stages of stellar life cycles, astronomers gain insight into the origins of stars, planets, and life itself. The incredible life cycle of stars is a fundamental part of the cosmic story, connecting the beginning of the universe to our existence. This journey from stellar birth to death is not only an astronomical phenomenon, but also a profound reminder of change and renewal in nature. In essence, every star is a cosmic storyteller, narrating a saga of creation, tumult, and inevitable transformation. As we gaze up at the night sky, millions of stars are continuously in different stages of this life cycle, silently unfolding their stories. Thanks to advancements in technology, we can now observe these processes in distant galaxies, expanding our understanding of the universe. Ultimately, The story of a star is a mirror to our own existence. Thank you for watching. If you liked the video, make sure to like and subscribe. Leave a comment too.